These are the solutions for the study guide for algebra, quiz number 20. And our first problem that we're going to end up seeing on the test looks like this, where we're asked to solve the quadratic equation by graphing. So basically I'm asking, well, first, do you understand what the solutions to a quadratic are? And so when we're solving a quadratic, we're trying to find the x-intercept. So we want to find out where is this graph going to cross the x-axis. And I also am testing you on what does a quadratic look like. And it always forms a U-shaped graph. And so first thing we're going to end up having to do is find out what the vertex is. And so I'm going to use this formula, the axis of symmetry formula, negative b over 2a. And so I take the a term, remember it goes ax squared plus bx plus c. And I take the a term and the b term. Negative 2 is b and positive 1 is a. And I substitute into the formula. So the opposite of negative 2 over 2 times by 1. And so this ends up, the opposite of a negative just makes a positive. 2 over 2 makes 1. So I take that 1 and I substitute. Y equals, and then 1 squared minus 2 times by 1 minus 3. So remember, there's always times in which you know you're doing something right if. And one of those is right here. And so when we're substituting the axis of symmetry back into the equation to find the y component of the vertex, the first two terms should always be opposite in sign, which they are, and one is double the other if you ignore the negative sign. That's what we see here. 1 is half of 2, 2 is double 1. So I end up with negative 1 minus 3, which makes negative 4. So my vertex is at 1, negative 4. And so I go ahead and plot that point. So over 1, down 4 spaces, put the dot right there, and then use the parent graph. Remember, this is just a y equals x squared. And so if you go over 1 space, if you square 1, if you go over 1, you put 1 in for x, you get 1 for y. And so we have these 2 points. And then from the vertex, if you square 2, so over 2 spaces, squaring 2, you get 4, so you go up 4 spaces. And then you have some other points. Let's say I went up 1, 2, 3, so I have to go up 1 more space there. So I go up right there, and those are our points that we're looking for. So before I go ahead and call off what those points are, again, you know you're doing something right if, well, right here, we have the y-intercept. If you set x equal to 0, we get y equals negative 3. So this is the y-intercept. Let's check and see if we have that. Right here, the y-intercept is negative 3, so we know we're doing something right. So these are our solutions that we're looking for, those 2 points right there. And so one of those was negative 1, the other was positive 3. So those are the 2 x-intercepts. And that's what we're going to end up boxing as our answer. So here we're solving a quadratic by factoring. And so that's the method that we have been working on for this test at least. And there are other methods, but I would just go with factoring because they all factor, and factoring is the fastest method if it works. So we have x and x make x squared. Now numbers that multiply to make 12, but subtract because they're opposite in sign to make 4, would be a positive 6 and a negative 2. See those outside terms and inside terms? Negative 2x, positive 6x, subtract to make 4. So I know it works. Well, then we use the zero product property. And so the zero product property says that we are going to find the value of x that makes this equal to 0. So I need to find the value of x that makes this expression equal to 0 and the one over here. So I'm going to take the 2 expressions and set them equal to 0. And I solve. And so it's just an opposite operation. So when you do this method, you're always going to end up with the opposite sign. Check to make sure you have that. So see how it says x plus 6? Well, when I went ahead and moved the 6 over, I get negative 6. So I have negative 6 as one of the solutions. The other one, notice how it's minus 2 here. You're going to add 2 to get it to the other side, to get x by itself, to find the value that makes this 0. And then 2 is the answer. So negative 6, positive 2 are the answers. So if you're getting 6 and negative 2, you're just looking at these 2 numbers here, but that's not the answer. The answer is when you move that term over to the other side, to use that zero product property. So on this one, I'm going to go ahead and factor again. So I'm subtracting 9 from all sides. I've got x squared minus 8x minus 9 equals 0. So I'll go ahead and factor. And I've got x and x to make x squared. And I'm going to go with a negative 9 and a positive 1. It works because negative 9 and 1 multiply to make negative 9. The inside terms make negative 9x. the outside make a positive 1x, and those will subtract to make negative 8x. So I know I've done the factoring right, so now I set the factors equal to 0. And so you can see how, again, if you're getting 1 and negative 9 as your answers, you're not using the zero product property. You've got to move that 9 over to the other side by doing an opposite operation. Same thing with the 1. So that's why it ends up being x equals negative 1 and x equals positive 9. Those are the solutions that end up working for x if we want to try to get 9 as a solution, or if we move the 9 over to get 0 as a solution. So let's take a look at the next set of problems. It says here just a little bit tougher factoring problem. So I've got to start with any prime numbers I see. So I see 1 and 3 multiply to make a prime number of 3. 1 and 3 are the only factors there. The next thing I see is that this is a positive. That means outer terms and inner terms add together to equal 10x. And so when I do this, I think I need to break the 8 down. I don't want to get a factor any bigger than 10. So I'm going to try to multiply the 3 by the 2x and the 1 by the 4x. If 4x and 2x multiply to make 8x squared, this makes 4x and 6x. Yes, that will work. That adds to make 10x. And so I'll go ahead and put the plus signs in there because they both have to be positive. And now I've got to set the factors equal to 0. So here, again, you got to use that zero product property. The first step is to move the term over. So if it's a positive factor, that constant there is positive, you're going to do an opposite operation. That's going to make it negative. And so from there I got to divide by the 2, and I end up with negative 1 over 2 as that solution. Over here, again, you're subtracting the 3. That's why it's going to be a negative 3 there. But then you also have to divide by the 4. And so you're going to end up with this fraction, negative 3/4, as that solution. Well, looking at the next problem, it's dealing with a projectile, or in this case sometimes they'll call these vertical motion problems. But in this case it's projectile because you throw the softball into the air and with an initial velocity of 38 feet per second at a vertical height of 5 feet. And so the vertical motion, or the projectile motion, of the softball is modeled by this equation. So this is half the acceleration of gravity right here in feet per second squared. And then over here we've got the initial velocity, and here we've got the initial height. And so what they're asking for, it tells us again, h is height in feet, t is time in seconds. Find the time it takes the softball to impact the ground. So you have to read what the question's asking. This tells us we need to set h equal to 0. So if they said find the time the ball is 1 foot above the ground, then we'd set h equal to 1. It depends on what they're asking. So now we know, okay, h is 0, so we can go ahead and start factoring. So if they set it equal to 1, well, then all you'd have to do is bring that 1 over to the other side to set it equal to 0 so that you could factor. So just like on this problem over here, let me go back to it. Here we had to bring the 9 over so we could set it equal to 0. So it's the same sort of concept. You'd have to just move a term over to be able to do the factoring. So when I factor this, I don't like to factor with my x squared term being negative. So I get rid of that. I'm going to divide this by negative 1, both sides of the equation. So I'm left with 16t squared minus 38t. That should be a t right there. Minus 38t minus 5. So I just switched all the signs. It makes the factoring easier for me because I'm used to seeing the x squared term as positive. You don't have to do it that way. I just choose to do it that way. So 5 and 1, the only numbers that multiply to make 5. Now, the outside terms and inside terms are subtracting to make negative 38. So I think I need to break the 16 down. And if I multiply the 5 by the 8, that makes 40. And if I put a 2 here, 2t, this makes 2t, and those will subtract to make 38. So to make it a negative 38, I need to make sure the 40 is negative and the positive 2 there, the 1 is positive. And then I'll go ahead and solve. And so I do this by using that zero product property. I set the factors equal to 0. And I'm coming up with 2 different answers. So we had seen before, you're subtracting 1, dividing by 8. So we end up with a negative 1/8. Here, I add the 5, so I get positive 5, and divide by 2, I get positive 2. So when we have this, when we're dealing with time or when we're dealing with a geometry problem, we're dealing with a distance, and we have a negative answer, a negative solution does not make sense. Solution does not make sense, because this would end up being a negative time. We can't have negative time. There is no negative time. So we're going to call this that extraneous solution. So we're going to cross this one off and just use this. We do that whenever we have a time or distance problem. So the time is going to end up being 5/2. Just change that to an easier number to represent, 2.5, and that's where we end up liking to use the decimal form or the mixed number form is when we're trying to understand what that number is. So 2.5 seconds is the time it takes that softball to hit the ground. Well, in this one, same sort of thing. We might end up with an extraneous solution when we solve because it forms a quadratic. We're going to end up with two answers. So here it talks about the volume of sandbox shaped as a rectangular prism. It says what the volume is. The height is 2 feet. Width is W, and the length is, right here, length is 2, or W plus 2. So use the formula. So volume equals L times W times by H to go ahead and solve. So let's substitute our numbers in. 48 equals L. Now L is going to be W plus 2. We're going to use that because we just want one unknown in the problem. And then we have W for the width times by 2. Well, what we can do, everything's being multiplied here. This is one number here, the W plus 2. It's being multiplied by W, being multiplied by 2. I can go ahead and use a little algebra trick to get rid of that 2. Divide by 2, but I got to divide both sides of the equation by 2, and I don't have that anymore. So now I have 24 equals, now I'm going to use the distributive property here, W squared plus 2W. I'll move this 24 over. So when you move a term, it switches signs. So now we've got this equal to 0. We can go ahead and factor. And so when we factor this, it's going to factor as two binomials. W plus 6, W minus 4 are the factors. And the reason is that 6W, 6 times negative 4 makes negative 24. 6W minus 4W makes a positive 2W. So when I go ahead and set the factors equal to 0, you're seeing how we're getting two different answers. We get W equals negative 6, W equals positive 4. So just as before, we have that extraneous solution. It's just an extra answer that doesn't fit the problem, the negative number. So we're going to go with this one right here. So W is 4. Now let's go ahead and find out what L is. And so 4 plus 2, well, that's where we're getting the 6 from. And so we'll say that the length is, and then what your units are feet, so 6 feet, and the width is 4 feet. So there we have it. So let's move on to the last three problems, a little review here. So on this one, we're trying to find x and then find the angle measures of this polygon. So what we're going to do is we're going to take all these x terms, 1.3 x. I'm going to move that over so it's not right on the line. I'm going to have 1.3x, and then I'm going to add on that 2.4x, and then I have just an x, and then I have a 2x, and then I have an x. So I'm going to use this column method here, so that because I know I'm adding up all those x terms, and then I'm going to add on the numbers 18 and 60. And so I add those two numbers together, and this is going to all equal, the answer is going to be 540, the sum of the angle measures, and that's what we have here. So when I add this stuff up, 1, 2, 1, 1, 2, 1, so that makes 7.7x. Over on this side we have 78, and this all equals 540. So I got to just subtract that 78 from both sides. And that leaves me with 462. Make sure again you borrow a little bit when you're doing that subtraction. And this all equals 7.7x. So you can see when you divide by 7.7, that's going to give us our answer, and it just goes in there evenly 60 times. So 60 is x, so I figured that out. Now you substitute. So it's just 2 times by x, and that gives me 120. And then 60 plus 60 makes another 120. And then over here we have to add 60 and 78. Well, that makes, or 60 and 18 makes 78. And over here we're multiplying 1.3 times by 6, and that also gives us 78. And 2.4 times 60 gives us 144. And all of these numbers, you can check them to make sure you did it right. You can sum all those numbers up. It should equal 540. So 144, 78, 78, 120, 120. You know, it's a good idea to check your work, especially if you got a little extra time. Check and make sure that all adds up to 540 degrees. So in this one, we have v equals 1/3 pi r squared h. We're trying to solve for h. And so we need to get rid of the 1/3 first. So the way we do that is we multiply by the reciprocal, just 3. And that's going to cancel out that 1/3. Everything's being multiplied, so you don't have to worry about 3 times these numbers because it's not the distributive property. No addition signs between those terms. So we have 3v equals pi r squared h. So now you're dividing by pi r squared, and we got our answers. So 3v over pi r squared equals h. That is that solution. So on this one here, they're asking for us to find out the distance between B and C. See, it says the diagram of the park. The triangles are similar, so that means we can set up a proportion. So this tells us we can use a proportion. And so we're going to set up fractions equal to each other. The crosswalk at point A is 20 yards. So crosswalk there, talking about this distance right here, is 20. And so we've got this triangle right here, 50 by 20. And so we're going to use that. And we're going to go 50 over 20. And I'm going to go ahead and cross off those zeros and just think of this as 5 over 2. Now I'm setting it equal to another fraction, or another fraction, yeah, but it's a similar triangle, and it's this one. So it says the bridge across the pond is from B to C. What is that length of that bridge? Well, right here's the other triangle. And you see how we can draw a line down from B to F, and that's going to be that third length. And so here I had 50 over 20, so I have to do 120 over this unknown. I'll call it X right here. And so I've got 120 corresponds with the 50 here, so that's why it goes on top, and then X corresponds to this length of 20. And so now I'm ready to go ahead and multiply. 5x equals 240. I get the 240 by multiplying the 2 and the 12, or the 2 times 12, and then adding the 0. So then I just divide by 5, and I get the answer. X equals 48. So we go back and look at the units there, and they are in yards. So we'll write 48 yards. So those are the problems that you'll see on this week's test. Good luck.